All right. We seem to be live. Let's check YouTube. So, what I discovered is that you need to keep refreshing YouTube. It doesn't start automatically. Really weird. Really, really weird. Really very good. Yeah, that's what I need to do. Okay. Let us begin. Today, I was thinking, yesterday I made a presentation, and we got to a point where I said, okay, I need to look at the Michelson Morley experiment because explain it I can explain it in other ways. That was my intuition. I've never looked into it. My intuition was that it's in my intuition was not that it's invalid. My intuition was that it has alternative explanations, that it doesn't really prove anything. But since then, so I started looking into it just a little bit and started thinking about it. And then I listened to a video that explains it. And the way they explain it, it's obviously an invalid experiment. The very experiment of Michelson and Morley is invalid, meaning it can never detect the speed of the medium, regardless of the medium. This is true for any medium. The Michelson Morley experiment, if they would have tested it with water waves, with sound waves, with any wave, or just do the math properly, they should, or the geometry or whatever, they should have realized that their experiments should always give what I would call null results. Their experiments should never detect the flow of the ether or the flow of any medium through which any wave travel, any waves that you're measuring, any wave that you're measuring, their setup can never detect the flow of the medium through which any waves that they're measuring is flowing. I know it's a little bit confusing. But let's go through it. So this is the video, special relativity. That's the video. So let me go to this tab. I think this is the tab. Okay. Yeah. So this is the tab, and this is the video. So I started watching it. You see, I didn't go all the way. So let me just click this and open it in another tab.
A
Let me
course
go to this
direction.
tab. Let's start over. I don't know if we need to watch the whole thing because really this is what I need to show you. This is the issue. So they're saying that the vertical, let me just, maybe we'll go to the beginning and review it step by step. I don't think it's necessary because my invalidation, my refutation of this entire experiment, the purpose, right? This experiment is supposed to prove the speed of the ether or detect the speed of the ether, but this experiment is not set up to detect the speed of the ether. It's an invalid experiment for its intended purpose. So let's look at this. So it says here overall it will take longer, right? Can you see my, I hope you can see my mouse, right? I hope you can see it. Overall, okay. So overall, it will take longer than the vertical. This is the claim. So I'm claiming that's never true. They should always take the same time. There's no reason they should take a different time. Longer than the vertical, because if so, this would cause. I mean, every time we would talk to people, we would get interference. We would always hear interference in real life. This should have effects in real life. We should hear a lot of interference because whenever waves travel somewhere and come back, I mean, if there was just a little bit of wind, we should get some interference pattern. We should hear like buzzing. This never happens. Whatever we hear, either we hear an echo that's different, but that's a little bit. Anyway, let's continue. So this is my claim. I didn't go through the math. I mean, I might be wrong. This is just I'm asking a question, right? Am I asking a question? I'm saying it seems to be invalid. My proposition is it seems to be invalid. So maybe we'll go through the actual math, and it's a little bit intricate. It's a little bit of a headache, but maybe we might have to. I don't know. Anyway, but here is the issue. There's definitely an issue if the way they're explaining it is the way that Michelson and Morley explained it. If this is the way that everyone explains it in the mainstream science, mainstream physics, if this is the way everyone understands it, and if this is the way Einstein understood it, then this is invalid. This should never have worked to begin with. This is just an invalid experiment. So overall, it will take longer than the vertical. They're saying that the horizontal, let me get rid of the subtitles. Their claim is the whole experiment just says there is a flow from the right to the left. The lines, the blue thicker lines are moving from the right to the left. This is the stream, whether it's water waves, or a water stream, or air stream, or the ether stream. Whatever it is, this is the medium, the imagined medium in this imaginary experiment, in this Gedanken. So it's moving from the right to the left. Okay, and therefore, this beam, well, I think they fired it from the bottom. Okay, they fired it from the bottom. This is the way this experiment is set up. I think you can see it here. This is the experiment, and then they did a close up, and the bottom is where the wave is coming from. This is wave theory. This has nothing to do with anything but just waves in general, just the theory of waves, just talking about waves. Don't let the word theory scare you. This is the way we generally understand waves, how they behave. And okay, so they're closing up. You can see they're closing up, closing up, closing up, and this is where we're at. Okay, so the wave started from the bottom. It hit this semi-translucent. It's a half-reflective mirror. So half of the wave continues straight up and then straight down, but it's a little bit deflected to the left because of the stream moving it to the left. Okay, but notice that they're showing a straight line as if it's a particle, which is it should already confuse you. We should not be seeing straight lines. What we should be seeing, this is why everyone gets everything wrong, because no one is ever imagining really, maybe that's my advantage that I always think back to waves as spheres, like yeah, I always think all the way. I never. I don't like these animations. I don't like these animations that It's okay to have a shortcut and tell me basically it's okay. Basically, it's nice, but show me the sphere and then do a cross section and show me a circle, the circles, and show me, and then you can show me a straight line. But don't just show me a straight line, because that's going to be bad for you, because because it's not a straight line. There is no line. This is a wave. A wave is not a straight line. A wave is a wave. Show me the waves. If you would show the waves, you would see the issue in your explanation. Anyway, so it's semi-translucent, it's semi-transparent, so it's semi-reflective, so half of the wave goes forwards and backwards, and then it goes to the detector. Here is on the right the detector. Did we check our audio? Yeah, I think we checked our audio. Yeah, yeah, I think our audio is fine. So very nice, and half of the wave hits the the half reflective mirror, goes to the left with the stream downstream, hits a complete mirror, full mirror, and then heads back upstream. So this is going to be very slow. Notice that if the speed of the wave is the speed of the stream, so the speed of the stream is from right to left, but now the stream coming back, the wave coming back. So imagine the stream moving from right to left is the speed of the waves. Then the signal, right? This wave coming from left to right is not going to make any progress. That's a black hole. At that point, we have a black hole, whether we're talking about water waves or sound waves or light waves. It doesn't matter. You're going to get a black hole. Okay, so, and this again, this demonstrates, this is just, okay, I'm not going to get, I don't want to lose sight of where we're headed. Okay, so when the signal travels from left to right, we expect it to slow down because now it's going upstream. It could end up not being able to make any progress. Okay, what happens at that? Okay, let's just continue just discussing the experiment. Let's assume in the beginning that it doesn't move. The water is not moving, or the medium is not moving from right to left. If it's not moving, then we expect, and they discussed this in the video, they expect the wave to hit this full mirror at the top, come back to this half reflective mirror, sorry, and head over to the detector while the wave from the bottom hits. We said half of it is going to hit the half reflective mirror, head towards the left, and come back at the same rate, and they should hit here at the same time, as long as all the distances, at least these two distances, are the same. Yeah, that makes sense. These two distances are the same. It's fine. The hope was, Michelson and Morley's hope was, that if the stream is from right to left, then on the way back, this signal is going to take longer, while this signal is not going to be impacted. And if that's true, and that's also the mistake, but let's I'm gonna show you that this is what this video says, and then we'll go through other videos. If everyone says this, we know that's not true. Of course, it's not true. I mean, obviously, it's not. We'll show that it's not true. This assumption is incorrect. It's not even an assumption. It's not. It's wave theory, or it's just looking at a wave. If they would have experimented with this in a water tub, if in a tub of water, if they could get a semi reflective mirror, which shouldn't be a problem, you could create a semi reflective would just be that, some of the waves, right? Some of the you're gonna have a mirror maybe with a hole in the center. It's possible to create it. It's not easy. Of course, with a computer simulation, we could do it, or with a finite element analysis computer simulation, we can recreate it. I mean, there's many ways to recreate this experiment today. I'm surprised no one has done this. If you do this in your imagination as a thought experiment, you would see this experiment is wrong. If you do anyway, if you ran it in any medium, you would see it's wrong. Meaning, you would always get a synchronized result at that detector. No matter what stream you get, you should always get a synchronized result. This has nothing to do with light. Light is not special. There's nothing special. The theory of relativity is not special. There's nothing special about this. It's not special relativity. There's nothing special about it. There is no theory of relativity. There's nothing special and there's nothing relative. It's just because we have internal clocks. That's the difference. The difference is that we are waving because light is, we are made ultimately out of light, or out of particles, that these elementary particles, they always move at the speed of light through this ether. This is why uh, we're getting anyway, we'll come back to to this. I mean, that's the only difference. I mean, when we look at this experiment in any medium other than the ether, other than the unified field or the fabric, call it whatever you want, so in any medium, it's clear that, I think, I mean, we didn't go through it, but that's my proposition. We'll try and prove it. I think we'll always get a synchronized signal. We're never going to get an interference pattern. The two waves are not going to be destructively and constructively interfering. We're never going to see it. It's always going to be a coherent signal coming in here. always. That's my intuition. Because I mean, I looked at what they said. What they said is incorrect. But we still have to go through and prove it. But on its face, I think I'm correct. But we'll go through it slowly. But my intuition is that we should always get a synchronized signal. Um, Now, you could argue that with light and with the ether, it's different because then our own clocks, every clock we could ever use, including our own biological clocks, are going to be affected by the flow of ether. Right now, ether is flowing right through us. As I've discussed before, this is the gravitational field. Earth's gravity is flowing through us, and that's what's dragging us towards the ground. That's what's dragging the moon into the earth. That's what's dragging the earth into the sun, and the sun into the galaxy, and all the galaxies and the clusters. That's the flow of the ether, of the fabric, of the unified field, which are all the same, in my opinion. So let's see, is do we have no comments, no viewers, and no one is visiting us? All right, it's okay. It's an interesting title that I gave it. I mean, but no, this means that YouTube is not sending anyone our way because even though I said I mentioned Michelson Morley experiment, well, no one cares about that. But I wrote the foundation of Einstein's special relativity. No one cares about that and seems to be invalid. All right, it's fine. Okay, we're 16 minutes in. Let's continue. So anyway, so let's now look at what they're actually saying. So I'll play this. Let me play it.
Longer than the vertical wave which faces no resistance but will get
Right. Let me show you the subtitles. His English, it's a little bit. It's like a little bit accent. So overall, it will take longer. So overall, the left and right beam or wave will take longer than the vertical wave, which faces no resistance. So they claim that this has no resistance. I don't know what they mean by resistance. Waves don't. There is no resistance. You cannot resist a wave by. I would say by definition, waves you cannot resist a wave. What he means is that this flow is not going to slow down the up and down of this vertical wave. But that's incorrect. I don't even need to say, I don't need to even prove it because this up and down is at the foundations. This is literally Einstein's thought experiment. This is his photon clock, where he has his, I would say, dumb photon, because it's a dumb thought experiment. The experiment makes no sense with the particle going up and down, and it makes no sense. Einstein, but nevertheless, this is literally Einstein's thought experiment, where Einstein says it moves slower as you have a stream moving through it. Of course, it's going to tick slower. So what do you mean no resistance? So either you're contradicting Einstein. You're contradicting. So I don't even need to say anything. You're contradicting Einstein's very thought experiment, which is the very foundation of his special relativity. Everything is based on this clock, on this moving clock. So if everyone says this, then they're all contradicting it. Everything is in contradiction. This makes no sense. Now, of course, the clock is going to tick slower. Of course, this is going to tick slower. This is a wave, and this wave, the shortest distance is actually along with the stream. It's going to hit here first. The wave will hit here first, but maybe I should draw. Let's take this picture. Yeah, let's take this picture. Let me make a snapshot. La 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 la. Maybe I should remove the subtitles, or maybe I should let him finish so you believe me. But I think he said enough. Let's continue. Let me see. Maybe he says something even more interesting, which faces no resistance but will get what?
get deflected towards the direction
It will get deflected towards the direction of the ether. So he claims that it's going to move sideways, but it's going to come back at the same time. That's incorrect. This is literally Einstein's relativity. Einstein says, of course, it will slow down. That's why a moving clock ticks slower relative to an inertial observer. How can you say that?
of the ether. To be precise, this is the time taken for the horizontal wave.
Okay, that's the horizontal. Let me see if is this the vertical?
And this is the time taken for the vertical wave where v is the speed of ether
Oh wait, so he is taking. Oh, maybe I'm completely wrong. Oh my god, am I completely wrong?
relative to the earth. So the horizontal wave takes longer by this amount.
Oh, so they did count. Okay, then everything I said is wrong. So they did take in. Oh my god, I thought I have. I thought I have something. Oh my god, this is so embarrassing.
So they would combine at slightly different times, which would result in two waves not being in phase. This would cause an interference pattern to be observed at the detector. If we keep rotating our setup, there would be a time when ether direction is horizontal and we should see the interference pattern. So we expect the detector to show varying intensities as we rotate our setup. But
Is this? Is this? I mean, so what I had in mind. What I had in mind was I'm looking at the edge case. The edge case is is a black hole. Let me. So he's taking at the edge. Let me look at this. So if he's taking everything into account, mm, then then he's not taking something into account. So if this is slowing down, he's saying this is slowing down and this is slowing down, then the only thing left is for Lorentz contraction. So that's the only other that's the only thing he didn't take into account, the Lorentz contraction. So that uh-huh. So in any other, so this should have, so it's just the Lorentz contraction. That's it. But but that's not, so he didn't, okay. The Lorentz contraction, the Lorentz contraction. I need to think about this. All right, I'm gonna have to think. I'm gonna have to. I wouldn't say go. It's like I was hoping that they completely missed this one. They didn't miss it, so it's just the Lorentz contraction that's missing. So there's the. I thought to disprove completely everything. I'm gonna have to look into a Lorentz contraction because that's the next thing that I heard about. If you take into account the Lorentz contraction, which comes out of Maxwell, so the claim is that according to Maxwell, you should get a contraction. So if the entire apparatus is becoming contracted, it should completely remove this effect. And the Lorentz contraction is due to electromagnetic wave theory. So, so in any setup, it should work. In any setup, you should. Anyway, I need to look into it. All right, forget it. I'm gonna have to take everything back for now. So the answer is no. I was wrong. All right, very embarrassing. Sorry. All right, see you next time. I'm gonna look into it. Bye.